Let us see today how to solve Lagrange's linear equation. So Lagrange linear equation is in the form PP plus QQ equal to R. So you know this P denote dou Z by dou X. This Q denote dou Z by dou Y. And this is an equation which has first order derivatives, right? First order derivatives. And the degree of this equation is 1, right? The degree is 1. The degree of the equation is 1. Hence it is linear equation. It is linear equation. And since P and Q represent partial derivatives, right? That's why it's partial differential equation and linear equation. If the equation is in the form PP plus QQ equal to R, then the equation is said to be Lagrange's linear equation, okay? That capital P, Q, R are functions of x, y, z. They are functions of x, y, z, okay? So first let us check whether the problem, okay, whether it is in the form of PP plus QQ equal to R. Then we start solving the problem. Question is solve this equation is the question. Solve the equation. Let's find solution of PDE, okay? PDE will be given. Solve the PDE and find the answer is the question. Okay. So we shall see the working rule to solve this PP plus QQ equal to R equation. So first we find what is PQR. Next we write dx by P is equal to dy by Q is equal to dz by R. So there are many equations here, right? If you take these two ratios, this is first equation. If you take these two ratios, second equation. If you take first and third, it is third equation. So there are many equations, right? So we call these equations as subsidiary equations. Subsidiary equations. Okay. So first you write dx by P equal to dy by Q equal to dz by R. Okay. After this step, we use sometimes grouping method, sometimes multipliers method. So we have to decide which method will give answer. Okay. So one is grouping method, other one is multipliers method. Okay. So we use according to the situation of the problem. Sometimes grouping method will give answer, sometimes multipliers method will give answer. Okay. What is grouping method? You can group any two ratios, integrate, find answer. You can group any other two ratios, find answer. Okay. So the the solution of this Lagrange linear equation will be in the form f of u comma v equal to 0, where u is equal to C1, which is the first solution obtained from grouping method. V is equal to C2, which is the second solution obtained from grouping method. Okay. So f of u comma v equal to 0 is the general solution, which is general solution of the given problem. So why do we say it is general solution? This f is arbitrary function, right? Arbitrary function. And you know the order of the equation here is, first order derivatives we have. So order of the equation is 1, first order derivative, so it is 1. So when there is a when there is a order of the equation 1, then the solution will contain only one arbitrary function. Or we can say like this: when the number of arbitrary functions and the order of equation, right? You look at the number of arbitrary functions and the order of the equation. If they are same, then the solution is said to be general solution. So it is general solution because order of the equation is 1. If the degree of equation is 1, then the equation is said to be linear equation. That's why we say this as linear equation. Degree of the equation is 1. Order of equation is 1. So solution will contain only one arbitrary function. And hence the solution is general solution. What is general solution? A solution which contains, say, equal number of arbitrary function and the order of equation is general solution. Okay. So by grouping method we can get solution f of u comma v equal to 0 You can group any two ratios, integrate, find first answer u is equal to c1, second answer v is equal to c2, f of u comma v equal to 0. Group any two ratios, get second answer. Okay. And we have our next multipliers method. You can choose multipliers L, M, N. Choose multipliers. We need two answers, right? Two answers. U equal to C1, V equal to C2. So let us choose another set of multipliers for second solution. V is equal to C2. So you can choose two set of multipliers. It is not must that you have to get solution. You have to get solution by using only multipliers. If possible, for first solution multiplier, second solution grouping method can be used. Okay. One solution can be obtained from grouping method, other one can be from multipliers method. Okay, if possible. So if it is not possible, you can get both solutions from multipliers, using multipliers. Okay. LMN, L dash, M dash, N dash. So you know, we have dx by p equal to dy by q equal to dz by r. Let us introduce another new ratio, LDX plus MDY plus NDZ divided by LP plus MQ plus NR. Okay. So this will give you answer 0. The multipliers, due to multipliers LMN, this LP plus MQ plus NR will become 0. If this is 0, okay, you will be able to get first solution. Okay. If sometimes it may not be 0, you have to do some adjustment to get 0, to get answer. Okay. Let us see in problems. LDX plus MDY plus NDZ. See, multiply numerator denominator by L, numerator and denominator here by M, here by N. Add, which is new ratio now, right? So this, if this is 0, from which you can take any two ratios, cross multiply this 0. You will get LDX plus MDY plus NDZ equal to 0, which will give you the first solution, U is equal to C1. Similarly, V is equal to C2. From these two, you can get f of u comma v equal to 0, the general solution. Okay. So, general solution. So, I hope you have understood the procedure. Let us see in problems again the same discussion. Okay. Let us do this discussion in the problem. Let us see first problem. Solve x square p plus y square q plus z square equal to 0. Let us rewrite it as x square p plus y square q equal to minus z square. So it is of the form pp plus qq equal to r, where p is equal to x square, q is equal to y square, r is equal to minus z square. It is of the form pp plus qq equal to r, where p, q, r, r. First let us write subsidiary equations. Subsidiary equations are dx by p equal to dy by q equal to dz by r. So it is possible to get answer through grouping method, right? Grouping method. So if you take first two ratios, each one is called ratio, right? And it is of the form a by b ratio. So take any two ratios, dx by, let us take first two ratios. Take first and second ratios. Dx by x square equal to dy by y square. Integrating. So partial integration is not allowed here, okay? Integrating. You take this to numerator, y power minus 2 dy. When you integrate, we know integration of x power n is x power n plus 1 by n plus 1. Similarly, here also plus constant of integration. Minus 2 plus 1 is minus 1. Here also minus 1. So you can see x power minus 1 is 1 by x. Y power minus 1 is 1 by y with this negative sign. C1. You can get this 1 by y this side. So this is of the form u is equal to C1. Okay. Similarly, we have to get second solution. See, let us take first and third ratio or second and third ratio. Your choice. Take second and third ratios. dy by y square equal to dz by minus z square. Integrating y power minus 2 dy, z power minus 2 dz. When you integrate y power minus 2 plus 1 by minus 2 plus 1, z power minus 2 plus 1 by minus 2 plus 1 plus c2. Minus minus get cancelled. 1 by z plus c2. Let us bring 1 minus 1 by z this side. Minus 1 by z. So which is v is equal to c2. U is equal to c1, v is equal to c2. So the general solution is, you can write answer. The general solution is f of u comma v. Where what is u? 1 by y minus 1 by x. V is minus 1 by z minus 1 by y. Let us write 1 by y minus 1 by x minus 1 by z minus 1 by y equal to 0. Which is the general solution. We call it as general solution, right? F of u comma v equal to 0. Okay. We shall see another problem. You can see the problem. PP plus QQ equal to R. It is of the form PP plus QQ equal to R. Okay. So first we write subsidiary equations. Subsidiary equations are dx by p is equal to dy by q is equal to dz by r. Okay. So through group it is possible to get answer, both answers from grouping method. Okay. So let us think whether first two ratios will give answer. If we take first two ratios, z get cancelled. When you cross multiply x dx, y dy, integration is possible. So from first two ratios we can get first solution. Okay. Take first and second ratios. Dx by yz equal to dy by xz. Both sides z get cancelled. X dx equal to y dy. Integration is possible. X square by 2 equal to y square by 2 plus c1. Bring this side, which will give you u is equal to c1 form. If you want, you can simplify this more, or you can stop. I stop here. U is equal to c1. Similarly, you take another two ratios. If I take second and third, will I get answer? If I take second and third, x get cancel both sides. Cross multiply y dy, z dz. So it is possible to integrate. Okay. So take second and third ratios. If it is possible, you can take first and third. Okay. Your choice. Take second and third ratios. Dy by xz equal to dz by xy. X get cancel. Y dy equal to z dz. Integrating y square by 2 equal to z square by 2 plus c2. Y square by 2 minus z square by 2 equal to c2. V is equal to c2. You can simplify this more, or you can stop. The general solution is f of u comma v. X square by 2 minus y square by 2 comma y square by 2 minus z square by 2 equal to 0. General solution is f of u comma v equal to 0. This is our u, this is our v. V is equal, right? F of u comma v equal to 0. So let us see next problem from multipliers method. Okay. You look at this problem. It is of the form PP plus QQ equal to R, where P is x square into y minus z, Q is y square into z minus x, R is z square into x minus y. First we write subsidiary equations. Subsidiary equations are dx by p equal to dy by q equal to dz by r. So here grouping method is not possible. If you take first and second ratio, I have x, y, z in the denominator. Here also x, y, z in the denominator. No terms will get cancelled. If you cross multiply, integration is not possible. Partial integration is not allowed. So integration is not possible. Grouping method will not give answer here. So we have to go for multipliers method. Okay. So we have to choose LMN. We have to choose LMN, which will make this LP plus MQ plus NR is 0. Okay. What is PQR? X square into y minus z. LP plus or minus sign here. MQ. LP plus MQ. 1 second. L into P plus M into Q plus N into R. This should become 0. Our P is x square into y minus z. Q is y square into z minus x. R is z square into x minus y. We have to choose LMN, which will give answer 0. Okay. What can be LMN? What can be LMN? See, if I choose, listen here, I have simply y minus z. If I leave x square. If I leave y square, I have z minus x. Simply x minus y if I leave z square. When I add y minus z minus x, x minus y, all will get cancelled. So what can be the multipliers? Now we have to think and do. Okay. We have to think and do. So if I divide this by x square, if I divide this by y square, if I divide this by z square, my answer will become 0. So one set of multipliers is 1 by x square, 1 by y square, 1 by z square. L, M, N. L is 1 by x square, M is 1 by y square, N is 1 by z square. You can see these get cancelled. Y minus z plus z minus x plus x minus y. Y get cancelled, z get cancelled, x get cancelled. See? 0. So we have to think and do. If we do more number of problems, at some stage, listen here, you will definitely guess what can be LMN. Okay. So through practice, you will guess LMN. Okay. So here, I have to introduce a new ratio, LMN, right? LP, L I have found 1 by x square, M I have found 1 by y square, N I have found 1 by z square. LP plus MQ plus NR, right? 1 by x square into y minus z. 1 by y square into z minus x. 1 by z square into x minus y. So listen here. I cannot multiply only here 1 by z square, right? I have to do it for numerator also. What is the new ratio? LDX plus MDY plus NDZ. Denominator LP plus MQ plus NR. You know dx dy dz, you know PQR. You have to guess LMN, which will make denominator 0, right? You cannot multiply LMN only for denominator. You have to do the same to numerator. If you add the terms, you have to add numerators. Okay. So this is 0. Just now we guessed, right? 0. Now take any two ratios. Let us take third and fourth ratio. dz by z square into x minus y equal to 1 by x square dx, 1 by y square dy, 1 by z square dz whole divided by 0. You cross multiply this. 0 equal to 1 by x square dx, 1 by y square dy, 1 by z square dz. So integration is possible now. Integrate. Take the term to numerator. X power minus 2 dx, y power minus 2 dy, z power minus 2 dz. Integrate. X power minus 2 plus 1 by minus 2 plus 1. Y power minus 2 plus 1 by minus 2 plus 1. Z power minus 2 plus 1 by minus 2 plus 1. Formula. Integral x power n dx formula. X power n plus 1 by n plus 1. which is equal to C1, constant of integration, which is minus 1 by x, minus 1 by y, minus 1 by z. U is equal to C1. Okay. Similarly, we have to find V is equal to C2. If you take second and third ratio, grouping method will not give you answer here. You have to go again for multipliers method, and you have to think what multipliers will make denominator. Sum or subtraction, we do not know. Let us check. Okay. Let us do another rough work. What is our next set of multipliers? L dash, M dash, N dash. M dash, right? LP plus MQ plus NR. Okay. Let us see what is PQR here. X square into Y minus Z. This is Y square into Z minus X. Z square into X minus Y. Let us decide what can give answer. Listen here. I told you already, right? So through practice you will guess the multipliers. So no one can say even in the first problem the multipliers. So through practice you will guess. Okay. So if I divide this by x, I have to do what I do, whatever I have to do for numerator also here, right here. If I divide this by x, I have to divide numerator also by x. Okay. So here I divide by y, I divide by z, and I add. If you divide, x get cancel, y get cancel, z get cancel. When you multiply xy minus xz, yz minus xy, zx minus zy. You can see xy, xy, yz, zx, zx. Answer is 0. So what is another set of multipliers? 1 by x, 1 by y, 1 by z. Right? So we shall do 2 more problems. Definitely you can understand. In first problem, whoever it is, they feel difficult to do, difficult to understand the problem. When you do second, third problem, it will be easy, definitely easy to you. Okay. So 1 by x, 1 by y, 1 by z. The second set of multipliers. LP plus MQ plus NR 0 here. Okay. Let us do. So there are 3 ratios already, right? X square into y minus z, y square into z minus x, z square into x minus y. Let us write the 4th ratio. I have to multiply numerator by x and denominator also by x, right? X square into y minus z by x. I should add similarly dy by y, y square into z minus x by y, dz by z, z square into x minus y by z. So take, this is 0, just now we confirmed, right? Take any 2 ratios. Take any 2 ratios. Dx by x, dy by y, plus dz by z, 0. Cross multiply. Dx by x, plus dy by y, plus dz by z is 0. Integrating log x, log y, log z, which is equal to C2, you can say. Since all are in log, let us add constant of integration, log C2. We know log A plus log B plus log C is log of ABC. So XYZ is equal to C2. Taking base E both sides, XYZ equal to C2. So which is V is equal to C2. Okay. Hence the general solution is f of u comma v. Already the solution u is minus 1 by x, minus 1 by y, minus 1 by z. V is xyz equal to 0, which is the answer. Okay. So let us do another problem from which you can easily guess how the multipliers are, right? How the multipliers are to the problem. Okay. So it's very easy. It's very easy. You can take PQR one side. So when you look at it, when you divide by x square, y square, z square, definitely the sum of other 3 will become 0. Similarly, when there is no square, definitely the sum of these 3 will be 0. So 1 by x, 1 by y, 1 by z, 1 by x square, 1 by y square, 1 by z square are the multipliers to this problem. Let us see another problem. Definitely you can understand. Okay. You can see the problem. It is of the form PP plus QQ equal to R, where P is 3z minus 4y, Q is 4x minus 2z, R is 2y minus 3x. We write subsidiary equations. Subsidiary equations are dx by P equal to dy by Q is equal to dz by R. So if you use grouping method, take first two ratios. We have here z and y, here x and z, where integration is not possible. Integration is not possible, right? So we have to go for multipliers method. Okay. So we have to choose multipliers, two set of multipliers, which will make LP plus MQ plus NR 0. LP plus MQ plus NR 0. What is PQR? 3z minus 4y, 4x minus 2z, 2y minus 3x. You add, subtract, do something, answer should come 0. You can choose some multipliers, LMN. LMN or functions or constants, anyhow, which will make the term 0, right? Let's see what can be LMN. I have here 3z. I have here 2z, right? I have here 3x. I have here 4x. I have here 4y, here 2y, which is the clue to find multipliers. See, x I have here, where it is here 4x, here 3x, right? 3x. Okay. So what it can be the multipliers? Can you guess? Can you guess? Here I have 3z, here I have 2z, right? So if I multiply this by 2 and this by 3, it will become 6z, here minus 6z, which will get cancelled. So 2 is a multiplier, 2, here 3, here 4. 2, 3, 4 are the multipliers. See, you multiply 6z minus 8y, 12x minus 6z, 8y minus 12x. See, 12x get cancelled, y, z get cancelled, 0, right? So 2, 3, 4 are the multipliers. So here 3z, there 2z. If I have 6z, it will get cancelled, right? It should be multiplied by 2, it should be multiplied by 3. Similarly for other thing. So LMN here are 2, 3, 4. LMN need not always be functions, x, y, z, okay? It can be constants also. So 2, 3, 4. So the first set of multipliers, now take multipliers. 2, 3, 4. So each of these ratios, dx by 3z minus 4y, dy by 4x minus 2z, each of these ratios is equal to the new ratio, 2dx plus 3dy plus 4dz divided by LP plus MQ plus NR. If I multiply this by L, I have to multiply numerator also by L. 2 into, right, 2 dx. 2 into this plus 3 into this plus 4 into this, which is 0. Right? Take any two ratios, first and last, second and last, or third and last. Cross multiply. I take third and last. Third and last, 2 dx plus 3 dy plus 4 dz. Cross multiply. 2 dx plus 3 dy plus 4 dz equal to 0. Integration possible. 2x plus 3y plus 4z equal to C1. So which is first answer, right? Let us take second multipliers. You can take the same 3z minus 4y, 4x minus 2z, 2y minus 3x equal to 0. Answer must become 0. So for what of LMN it will be 0? First I went through the constants 3, 4, 2. Now I go through the function. I have here with 3 I have x. With 3 I have z. Okay. With 4 I have x. With 4 I have y. With 2 I have z. With 2 I have y. So what I should do is, here I have 3x, here I have 3z. If I have 3xz here 3xz, they will get cancelled. So it should be multiplied by x, it should be multiplied by z, it should be multiplied by y. Which is, see, 3xz, 4xy, 4xy, 2yz, 2yz, 3xz. You can see xz, xz, yx, yx, yz, yz, 0. Hence, the other set of multipliers, another set is xyz. Okay? xyz. Take multipliers x, y, z. Each of these ratios is equal to, instead of writing all the 3 and writing 4th ratio, you can write each of these ratios is equal to x dx plus y dy plus z dz divided by x into this plus y into this plus z into this, which is 0. X into this, so x should be multiplied with numerator also. Y into z into LDX plus MDY plus MDZ by LP plus MQ plus NR. Take any one of the ratio. Cross multiply x dx plus y dy plus z dz equal to 0. Integrate x square by 2, y square by 2, z square by 2 equal to C2. V is equal to C2. Hence, the general solution is f of u comma v or v comma u, whatever it is equal to 0, which is the solution. Okay. Solve x into y minus z into p plus y into z minus x into q equal to z into x minus y. So this is of the form pp plus qq equal to r. The subsidiary equations are dx by p equal to dy by q equal to dz by r. This is subsidiary equations. Okay. It's very clear grouping method is not possible. If you take first and second ratio, integration is not possible. So grouping method is not possible. You have to go for multipliers method. Let us consider, listen here, we have to take two set of multipliers. Take multipliers. See, it is PQR. Let us take in the rough work. I want LP plus MQ plus NR equal to 0. What is PQR? X into y minus z. Or I can write xy minus xz. Yz minus yx. Zx minus zy. Answer must come 0. Listen here, PQR. I have to choose LMN, which will make the answer 0. It's very clear. If I add simply, it will become 0. See, xy, xy, xz, xz, yz, yz. So the multipliers are simply 1, 1, 1, 1, 1, 1, or 2, 2, 2, or 3, 3, 3, whatever it is, your choice. 1, 1, 1, 2, 2, 2, 3, 3, 3, whatever it is. You should not say 1, 1, 1 as first answer, 2, 2, 2 as second answer, okay? So you can choose any one because there is reason. Answers must be independent. You cannot say 1, 1, 1 as first answer, 2, 2, 2 as second answer. Okay? So 1, 1, 1 is the, this is the set of multiplier, first set of multiplier. 1, 1, 1, because simply multiplying this Adding will give you answer. So here multipliers are 1, 1, 1. Each of the ratios is equal to 1 dx plus 1 dy plus 1 dz by 1 into this term plus 1 into this term plus 1 into this term, which is 0. Take any ratio, dx by x into y minus z equal to dx plus dy plus dz by 0. Cross multiply. Dx plus dy plus dz equal to 0. Integrating. X plus y plus z equal to c1. So first answer over, right? Let us take another set of multipliers. Take multipliers. Let us do rough work first. It is x into y minus z, y into z minus x, z into x minus y. It need not be always addition in between, okay? So the sign we have to choose, which will come answer 0. Okay, ma'am. So here, see, what it can be another set of multipliers. Just now we have done similar problem, right? X square into y minus z plus y square into z minus x. Just now we have done. The same here. So if you leave these three, when you add, answer is 0. So this should be divided by x. It should be divided by y. It should be divided by z. Right? It should be divided by x, y, z. So that these get cancelled. Simply adding the 3, answer is 0. So the multipliers are 1 by x, 1 by y, 1 by z. 1 divided by x. Right? So listen here. If I divide this by x, that is 1 by x. If I multiply by 1 by x. 1 by x. Right? So if I divide by x, I have to divide numerator also by x. Right? So the multipliers are, just now we discussed, right? In a problem. So each of the ratios is equal to dx by x plus dy by y plus dz by z. Then similarly divide each of these x, y, z, add. If you add, you will get 0. Sometimes when you do subtraction, it may be 0. The sign we have to decide, okay? So let us take any one of the ratio, which is dx by x plus dy by y plus dz by z. Cross multiply. Dx by x plus dy by y plus dz by z equal to 0. Integrate. Log x plus log y plus log z equal to log c1. C1 already, right? C2. Constant of integration, simply C2. If you want, you can do simply C2. Since everywhere log, I write constant of integration also as log C2. Log A plus log B plus log C is log of ABC. Take base E both sides. X, Y, Z equal to C2. V is equal to C2. Hence the general solution is f of u comma v. F of u comma v or v comma u, whatever it is equal to 0, which is the general solution. Okay.